Today I want to add on a few more points to the previous video, which was on simplification, before we get into estimation, which will be today's video. So I want to talk about Kung Fu and Kung Fu masters. What does that have to do with anything? Well, in the last video on simplification, we talked about being efficient and being lazy in a good way. So a Kung Fu master, an old guy, when faced with a young guy doing some razzle-dazzle routine with nunchucks, who usually wins in that interaction? The old guy, because he has to only do 2 or 3 things which he's practiced millions of times, and he also has thousands of ways of getting these guys onto the ground. So the point is, seek to be a Kung Fu master in doing this stuff. Don't just try to do it any which way. Look to be efficient. Try practice it many different ways till you feel very fluent with it. All right. Next, I just want to mention, even with simplification, before you can simplify, you're already scanning the problem. So a lot of these habits and skills we've been talking about build on top of each other. All right, so today we're going to start with estimation, and I have 2 main points I want to throw out, which is most people don't do nearly enough of it, so do more of it. And the second point is we're going to go through several aspects. That'll be number 1 through 4. Number 5 we'll do in the next video. Okay. So these aren't meant to be super difficult problems, but they're just meant to illustrate a few points. So let's say we want to estimate what this fraction is. We could round the 41 to a 40 and the 99 to 100. So it would be 40 over 100, or 4/10. Okay? Then we go to this one. We might say, let's make this 1,000, let's make that 8,000, so this would be rounded to 1/8. The point is, what should you round to? Notice I haven't told you what to round to, so it's dependent on the context. So I don't want to always tell you what to do. Part of getting good at this is knowing it makes more sense to round to the tens here, whereas it makes more sense to round these to the thousands. All right, so that's illustrating it depends on the context where you should be rounding to. All right, number 2. So you might be tempted to say, let's just estimate this, round this to 30, round that to 80, round this to 40, round that to 190, round everything to the tens. That seems reasonable. Or you might notice that the 31 and the 186 simplify perfectly. And then actually these 2 do as well. Okay, and now you might say 7 over 78 is approximately 7 over 77, which is 1/11. So notice here the point is we're combining estimation with exact calculation and simplification. So estimation is not an all or nothing thing. You might do it for a little bit and then do something else and chain it with other things. So you're not necessarily in either purely calculation mode or purely estimation mode. All right. Whoops. Let's make this. Okay. So this is 443 times 507, and let's say somebody's doing this work and they got 2048. Without checking the entire calculation, let's use a few tricks to see whether this is correct. So first of all, notice the 3 times the 7 should end in a 1 because that's 21. So that's an 8 and not a 1, so already we know it's wrong. Now let's use an estimation argument to see why this is wrong. 43 is about 40, and 507 is about 500. Now 4 times 500 is already 2,000. But 40 times 500 would be 20,000. So this is off by an order of magnitude. So that's another application of estimation. It helps you check your answers. All right, now let's go to number 4. So number 4 is 9 over pi squared. For those, most of you probably know what pi is. For those that don't, it's 3.14 and a ton of other digits. We'll just think of it as 3.14 for the time being. So 9 over 3.14 squared we might say, hey, let's just throw off this garbage over here and treat this like 9 over 9, because 3 squared would be 9. And we get 1. All right, so that's a pretty nice estimation example, but I want to mention one other thing. So let's say you estimated this to be 1, and you want to know, is the true answer higher or lower than 1? So for that, I want to introduce a concept of qualitative versus quantitative. Quantitative deals with numbers, quantities. Qualitative deals with qualities, so higher, lower, fatter, thinner, heavier, skinnier, whatever. So in other words, this is a direction or a quality, not necessarily how much. So if I'm 36.753 inches tall, I'm being quantitative. If I say I'm taller than Bobby, I'm being qualitative. All right, so we're approximating pi squared as 9. Now, if we had used 3.14, pi squared would have been larger than 9. So 9 divided by a larger number would shrink more. So in other words, the true answer is below 1. So here we're using a qualitative idea rather than exactly calculating to see, okay, 1 is sort of an upper limit on our answer, and the real answer is going to be a little bit below. All right, I'll leave it there, and in the next video, we'll go into number 5.